Okay, so in this video, I'll explain about the port structure of ATmega 16 microcontroller. There are four ports: port A, port B, port C, and port D. All ports are bidirectional ports. It means they can be used as an input port or as an output port. We have option for internal pull-ups. Internal pull-up are there which can be connect or disconnect to the port pin. Okay, so we have internal pull-ups. They can be enabled or disabled to the port pins. Individual port pins can be configured as an input mode or output mode. Okay, so let's first understand the port configuration, how to configure a pin in the input or output mode. So to configure a pin in the input or output mode, we have different direction control registers. So we have four registers: DDRA, DDRB, DDRC, and DDRD. These are called direction control registers. We can control direction of a port pin using these registers. These are 8-bit wide. So let's look into the DDRA register. So it's an 8-bit register. So this first bit is corresponding to the pin PA0. This bit is corresponding to PA1, and so on. This pin is corresponding to PA7. Okay. And so to configure a pin in the output mode, we have to write 1 to the corresponding bit position in the DDRX register. So let's say, for example, we want to configure PA0 in the output mode. So we have to write 1 here. So we have to write 1 to the first bit position, 1 here. To configure a port pin in the input mode, we have to write 0 to the corresponding bit in the DDRX register. So for configuration of PA0 in the input mode, you have to write 0 here. Okay. Now, if you look into the internal structure of the port, then okay, so let's look into the port structure. Okay, so now we have this we have a flip-flop DDX. So here X could be A, B, C, or D, or N is the pin number. Okay, now this flip-flop is a part of DDRX register. So when we write 1 in the DDRX register in a particular bit position, so this 1 is available in the output of this flip-flop. Okay, now this 1 is connected to a tri-state buffer. Okay, so this 1 enables the tri-state buffer, and now this tri-state buffer is connected to a flip-flop. Now this flip-flop is a part of port data register. So we have four such registers: port data register, port A data register, port B data register, and C and D. Okay. So the data available on the output of this flip-flop will be reflected on this pin. Okay. So let's say, for example, the port data register contain 1. Okay. So for example, this is the pin number, this is PA0, and the port A contain this number. So in the first bit position, let's say we have 1 here. Okay, so this 1 will be available on this pin. Okay, so this will be logic level, this will be at logic level 1. Okay,